Hey, okay, here's the video you requested. Sorry I look so bad. I just woke up. Okay, first things first, I'm gonna make you a diagram. Here's your diagram. I know this is probably gonna be, I don't know if it's gonna show up as flipped because I'm videotaping this on my Mac, but okay, here's your hand. You're going to take your left hand and with your palm facing up, you're going to place it on the piece of paper. Remember, palm facing up, bottom of your hand, top of your hand on the paper. You're going to trace it like that. My fingers really aren't that fat, but I just made it really big. The top one is going to be pi over 2. The index finger is going to be pi over 3. Middle finger is going to be pi over 4. Ring finger is going to be pi over 6. Pinky is going to be 0. The reason why we do this is because imagine your hand like the first quadrant. Here's the quadrant right there, okay? There's your x-axis and your y-axis. So your y-axis at the top, this is 90 degrees right up here. If you start from here and you go up, there's 90 degrees. That's why that's pi over 2, goes straight up. X is going to be 0 degrees if you just start out. That's your starting point. This is your first quadrant. I don't know if it looks like your second in the video, but you get what I mean. And then here's your, there's X, going to start at 0 degrees. If you go up to 30 degrees, there's 30 degrees. It's going to be pi over 6. Go to the next 45 degrees, it's going to go to your middle finger, pi over 4. You go to the last one, 60 degrees, is going to go to pi over 3. So copy this down. And just remember that this is flipped, so make sure you copy it right so you don't get confused later on. There's that. And then I want you, or you know that your ordered pair looks like this. Cosine, comma sine. That is your ordered pair. So what we're going to do now is, let me just draw these in my fingers. Pi over 3. See how much I do for you? I'm drawing on my own skin. There's my hand. 90 degrees, that's a crabby 90. Pi over 3, pi over 4, pi over 6, 0 degrees. There's my hand. Okay, so now we're going to do some examples. Well, first let me give you the formulas. Those are formulas. So you can pause the video and write these down, and then let me explain to you why. Let's just say I had an example of sine of pi over 3. So if I have pi over 3, my index finger, remember, is my pi over 3 finger. So I'm going to pull back my pi over 3 finger. Once I pull my pull it back, it's this whatever you're holding, whatever finger you're pulling back, that's going to represent a barrier between your top fingers and your bottom fingers. Just remember, like in the ordered pair, when it's cosine, comma sine, remember the top fingers represent cosine, the bottom fingers represent sine. So just whatever finger you're pulling back, whether it's your index, your middle, or your ring, just remember that that's going to serve as the comma. So let's just say I had sine of pi over 3. So here's my pi over 3 finger. That is going to be my index finger. I'm going to pull back pi over 3. Now remember I told you it's going to be cosine at the top, sine at the bottom. So since I'm looking for sine of pi over 3, sine's gonna be my bottom fingers. So your answer is gonna be the root of your bottom fingers over 2. So sine of root 3 over 2. The reason why it's like that is because all the formulas that I just held up, I'll hold them up again. Sine is equal to the root of your bottom fingers over 2. Cosine is equal to the root of top fingers over 2. So let's just do the example one more time. Cosine of pi over 3. I just did sine over 3. Now I'm doing cosine of pi over 3. Cosine of pi over 3, if I pull it back, my cosine fingers are going to be these at the top. So I only have one finger at the top. It's going to be the root of 1 over 2, which equals 1/2. So I hope you get that. Let me just do a couple more examples so it makes more sense. Okay, sine of pi over 6. Let's sine of pi over 6. When you look at your hand, pi over 6 is going to be your ring finger. Oh, you just boxed me. Okay, here's your pi over 6 finger. I'm going to pull back my pi over 6 finger. Okay, so now since I pulled it back, I'm looking for the sine of pi over 6. So now you know that the bottom fingers always represent sine. So now my formula for sine is, remember, 2 over the root of my bottom finger. The root of my bottom fingers over 2. So the root of my bottom fingers, I only have 1 at the bottom. It's going to be the root of 1 over 2, which is 1/2. So there it is. Now let's do cosine of pi over 4. Cosine of pi over 4, here's my hand. I'm going to pull back my pi over 4 finger, pull it back. Cosine is the top fingers. The formula for cosine is the root of your top fingers over 2. There's only 2 fingers at the top, so your answer is going to be root 2 over 2. Now let's do tangent of pi over 6. I wrote these in pencil, but then I was like, you can't see them, so let me just write them in Sharpie. So tangent, and plus I like the smell of them. Tangent of pi over 6. Here is my pi over 6 finger. Now for tangent, there's a different formula than sine or cosine. Instead of it being the root of your top fingers over 2, tangent's different. Tangent is going to be whatever finger, whatever it's asking for. So it's asking here for pi over 6. Whatever finger it's asking for, you're going to pull back that finger. So right here it's asking for pi over 6. I pull back my pi over 6 finger, and I'm going to flip my hand. This is only done in tangent examples. It's not done in any other example, yet you have to flip your hand. Only in tangent. So again, pi over 6 finger, pulled it back. Here's my hand straight. Flip it. Now the tangent formula is the root of your top fingers over the root of your bottom fingers. There it is. Root of top over root of bottom. So again, pi over 6, pull back, flip, root of top, there's only 1 at the top, so root of 1 over root of 3. Answer is 1 over root 3. Okay? And then once you simplify that or rationalize that, your final answer is going to be root 3 over 3 because you can't leave a root in the denominator. And then so that's how you do sine, cosine, and tangent. To get the reciprocals, the secant, cosecant, and cotangent, you're just going to flip the values, whatever I gave you for cosine. So for cosine, instead of it being the top fingers over 2, secant's going to be 2 over the root of top. So if the answer for your cosine was root 3 over 2, secant's going to be 2 over root 3. Same thing with sine. With tangent, whenever I have a value, I pull back that specific finger, then I flip my hand, and then I take the root of the top, and then I take the root of the bottom. Because remember, whichever finger I pull back represents my barrier. So the root of the top over the root of the bottom. But when it comes to cotangent, I'm not going to flip my hand. I'm just going to take the root of the top over the root of the bottom without flipping my hand. Tangent is the only one where you flip your hand, then take root of top over root of bottom. But cotangent, you don't flip it, and you take root of top over root of bottom. If you think about it, that is the reciprocal. So if I have tangent of pi over 3, and I want to know the answer of tangent of pi over 3, I'm going to flip my hand. It's going to be root 3 over root 1 equals root 3. If I was to flip that, it was going to be 1 over root 3. 1 over root 3. But if I didn't flip my hand, again, root of top is just 1, root of bottom is 3. So in cotangent, you don't have to flip your hand. It's just going to be root of top over root of bottom. So those are all the formulas. You can pause the video and write them all down, all 6 functions. The last thing I guess I have to tell you is how to solve if you have like cotangent of 5 pi over 6, or like something that has like a 5 or a 7 or an 11 in front of it. Draw out your axis, and then remember, all students take calculus. So in this quadrant, everything is positive. In the second one, only sine and its reciprocal, cosecant. In the third quadrant, only tangent, cotangent, and the last one, only cosine and secant are positive. So this is, I guess, a positive chart. Okay? And then what you're going to do is if I gave you an example of cosine of 5 pi over 6. There's your example, cosine of 5 pi over 6. So what you know that at this point you have 0, and over here is pi, meaning 0 degrees and 180 degrees, but this side is pi. So what you're going to do is if you have 5 pi over 6, what we have, I guess whatever form, I guess you can call it, whatever form this is in the pi over 6 form. So you're going to put pi over 6 over here on this thing, but I guess manipulate it to make it a 1 whole pi. So if you have pi over 6, what I'm going to do over here is I'm going to make this 6 pi over 6 on this end. Okay? It's just easier to see that way. 6 pi over 6 simplifies to pi, and now we have it in the form that our question is asking in. Because it's asking for 5 pi over 6, so I made this in 6 pi over 6. So you know that if this is 6 pi over 6, the other end where it's 0, if you were to start at 0 and go all the way around, here's 6 pi over 6. Go back around 360 degrees, this is going to be 2 pi. So here's 2 pi. So then you think, what can I manipulate pi over 6 to make it 2 pi? So that's 12 pi over 6. There's 12 pi over 6. Simplify that, you get 2 pi. You get the idea. So now first I'm going to do cosine of 5 pi over 6. So if I have cosine of 5 pi over 6, I know that this is 6 pi over 6. This is 0, but then if I go back around, there's 12 pi over 6. So now that 5 pi over 6 has to land before 6 pi over 6, meaning it lands in this quadrant, in the sine and cosecant quadrant. So now I know where it lands. So now based on whatever's in this quadrant, I know that the only things possible that can be positive in this quadrant are any sine or cosecant values. This is a cosine, so it's not going to be positive. Your answer is going to be negative. The only reason why they give you 5 pi over 6, 7 pi over 6, 11 pi over 6, anytime they give you another number, the only reason why they give it to you is so you could figure out where on the unit circle it lies and if it's going to be positive or negative. So we know that cosine of 5 pi over 6 is going to land over here, so the answer is going to be a negative in it. So now you're done with the 5 pi. All you have is cosine of pi over 6, and you already saw from like 2-3 minutes ago that cosine of pi over 6, here's your hand, pi over 6 is going to be this finger, and remember it's going to be the root of your top over 2, so it's going to be the root of 3 over 2. Your final answer is negative root 3 over 2. Now if I were to do cosine of 11 pi over 6, again, you have pi over 6. We already have it. Here's 6 pi over 6. I manipulated it. Here's 12 pi over 6. You know that 11 pi over 6 is going to land in this quadrant, and in this quadrant, cosine and secant are positive. So in your problem, it's looking for cosine. So your final answer is going to be positive. It's going to be positive, and then again, pi over 6, just like this problem, cosine of anything of pi over 6 is going to be root 3 over 2, because again, here's my hand, pi over 6, pull back, top fingers over 2 is the formula for cosine, so my final answer is going to be root 3 over 2. But this time it's going to be positive. So over here would be 7 pi over 6, and that would be negative because it's not in but if I had just pi over 6, it would be in the first quadrant. Everything's positive in the first quadrant. That's why cosine of pi over 6 by itself is always going to be root 3 over 2. And if you have anything like cosecant, secant of 6 pi over 6, or sorry, 5 pi over 6, 5 pi over 3, anything that you have, just make this, because all it's asking for is either the positive or the negative. So you need this, you need to memorize these, and then you need to memorize these formulas, and you need to memorize your hand diagram. So once you memorize all those 3 things, you are going to be good to go, and you're going to make an A+ on your test. I'm going to stop this video and put it on YouTube so you can see it. I am sorry I look so bad, I just woke up. But I hope you enjoyed my video, and I hope you liked seeing my face. Okay, bye.